Welcome everyone to Data Science from Zero to Hero. Today the topic is exploring data. What is data? How do we get it? What is NumPy? What are the spreadsheets? What are CSVs, blob, JSON, arrays, list? I can go on and on. But yeah, this is today's topic. Before understanding what is NumPy, let's understand the basics of how we get the data. So in any organization, we get the data in form of CSVs, in the form of Excel spreadsheets, or JSON data in the form of JSON. And also in some cases, there can be a blob. We'll talk about blob little later. It is mostly used in Microsoft Azure. But apart from that, let's deal with list, or in layman terms, an array. So what is an array? Array is something which stores identical elements, more like a collection. For example, here if you're looking at this is an array of integers. Array 1 contains 1, 2, 3, 5, 6, all sort of integers, you can all sort of numbers. So array 1 is called as, this is 1. And if you look into the second one, there is array 2, which contains elements in the form of string. So this is an array of string. But wait a minute, it is showing us some error here. Looks like it's not closed, but I did close. Let's see. So what does this say? So there is some syntax error. Where am I missing and what am I missing? Exactly. So this is an array of string. You can interchange array with bliss anywhere. Now let's say we have a random data. Let's say the data is containing elements like probably marks 50, 12, 18, basic percentile 18 or 38. Somebody has scored 100, or somebody has scored 99, somebody has scored 67, 68, or something like that. Okay, so this is general data, and the way how we try to print it up is using print function, which is sorting out and this way. And we can either click on this button, this run cell, or else we can just tap and shift enter. This gets run. This is one. No, but all these don't provide or not optimized. But all these are not optimized. But all these are not. This is how you typically. So this is how you typically get the data, and you try to store it in the form of arrays, or in our case list. But all these don't provide or not optimized for numerical analysis. Now that's where NumPy packages come into play. But why can't we use existing arrays or less as it is? To understand this better, let's look at the differentiating factor. So what are we trying to do here is we are importing this as NumPy as, you can call it, let's say for example, F. Okay, just I'm using F as a reference. So if you use F, you need to call it via that same functionality. So you call it by f.array and the data whatever we are trying to pass, and we are calling it as marks. So now when I try to send it, you will be able to see that this is a list and this is an array. So what are we essentially trying to do is we are converting its type. This is one thing that you can just blatantly see. Okay, so just in case you are wondering about the difference between a list and a NumPy array, let's compare how the data types behave when we use them in expressions. For example, what do I mean when I say expression? Now let's say we have the data, right? So so print, let's say the type of data. Okay, and this particular data I wanna x2, so I'm just multiplying it with 2, so the entire data into 2. Now this is a way how we can check what is happening on this layer. Similar thing for our marks as well. So print type marks, and this marks I'm going to multiply it with 2. Oops. Now, so marks is going to be multiplied with 2. Let's just have one small differentiating factor. Let's call it okay. Now run it. So if you see, one is classified or termed as list. The class is called list, but there is another one where it is calling itself as numpy nd array. But what is essentially happening inside that? So data is getting multiplied by 2. So if you see, initially it was probably 50. Note that multiplying a list by 2 creates a new list of twice the length with the original sequence of list elements, which are repeated. But multiplying a numpy array, on the other hand, performs an elemental wise calculation in which the array behaves like a vector. So we end up with an array of same size in which the element has been multiplied by 2. So that is a difference. So the key takeaway from this is NumPy arrays are specifically designed to support mathematical operations on numeric data, which makes them more useful for data analysis than a generic list. That's part one.